Hi, welcome back to the channel. Thanks for tuning in today. Well, I have the crankcase, which is totally empty, for the 185. So this is engine number one. I'll be doing the reassembly on the crankcase today. There's a lot of dimensions to check on this engine to make sure everything fits properly. You go, well, it's just a little one-cylinder engine. It's actually quite complicated, and I'm going to go through the whole process here, measure this up so that I can determine the correct shim pack for the end play on the crankshaft. Super important, so let's get started. Here's the diagram that has all of the dimensions on it. So dimension A is actually the depth in this half of the crankcase. B is the depth in this half of the crankcase. E and D are the width of the bearings. F is the width of the spacer. Here's our shim pack that we have to determine what we're going to use. And then we have to measure the width of the crankshaft across the center, come up with a number to end up with the proper shim pack in here. And the end clearance on the crankshaft actually comes from the thickness of the gasket that goes in between the crankcase halves. So it's a pretty neat system, a lot of measuring. So let's get measuring and see what kind of numbers we come up with. So I'll be using a depth micrometer. It comes with a lot of different attachments so that you can go and use any depth that you'd like. This is the one for the range here. These two faces here touch on the crankcase half, and then I will gently hold it down, a little pressure on it, and then we'll turn it down, and I have a dimension, and I'll lock it, and then we'll read it up and see what we have. I'll record that dimension on the board. So same process on the mag half. I'll just gently hold it, and we'll measure down. I would say that that's good. I got the same number 3 or 4 times. So I'll record this dimension now on the board, and then we'll do all the math later. So transferred over to 1-inch micrometer now. So we have to get the overall width of the main crankshaft bearings. I'm happy with that sizing on that one. Let's check the other one. Yes, exactly the same. Okay, so perfect. So I'll record that on the board. Next part is our spacer. Goes on first before the bearing. Well, that feels pretty good there, and oh, it's very well machined. Okay, I'll record the dimension on the board. So the next dimension that we need is the overall width across to the outside of both of the flywheels. Now, this side it's completely the same. It's flat all the way across. So if I measured at the outside, I would be the same as on the inside. Oh, look, it was the 11th month of 1981. Anyway, back to what we're doing. So this side is flat. This side, however, is not. You can see this raised shoulder that's on here. So I don't have anything that I can get around it to measure it accurately. So I'm going to be doing this in 2 steps. I'm going to use the micrometer for the overall width, and I'm going to use a height gauge to get this height above here and then add it together. So I'll be right on. So let's check this right now and find out how high that actually is. We'll use this little gauge here and see what we, see what we get from this. Okay, let's turn it on and make it touch and zero it. Let's just check the zero. Okay, I'm happy with that. I'll lift it up a bit. It's got magnet feet on it, so it's staying nicely on here. And check the height, 41.5. I'll do this a couple of times. 41.5 thou. So I'll record that, and then I'll get the dimension with the micrometer next. So time to get the overall on the flat surfaces where we can do that. We go with 1,772. So I've added the two of them together. So dimension G is 1.8135. So I'll record that on the board now. So I have all of our individual dimensions down here, as you can see. So let's go by the three boxes of the equation here and figure this out. So the first box is C, which is A plus B. So let's do that. 1.875 plus 1.5225 equals. So the answer here is 3.397 and a half. Okay, so this is C right here. C equals that. Next one we need to do is H, which is we have to add together D, E, F, and G. So D, E, F, and G. So let's add these ones together and see what we get here. So 0.592 plus point. Nope. No, that was right. Okay, let me start again. Let me go back to D here. So 0.5902 plus 0.5902 plus 0.3567 plus 1.8135 equals. So H is 3 inches, 350 and 6/10. So this is H. Now, okay, I is the next one, and it's that one there is actually a -1. So we're going to take C, which is right here. So we're going to take 3.3975 minus an H. So this is our number here, minus 3.3506 equals point. Okay, so I, so this one here, so I equals 0.469. Whoops, 0.469. Let's do this again properly. 0.469. Okay, now that's the shim that we're looking for. So this is the answer. This is why we did all of this and measured all of this to find out what the unknown shim is. So that's 0.469, so 47 thou. And the shim that's in it, I've measured it already. And the existing shim is 0.040. So we're shy by 0.007 of an inch. So I will look and see if I can find a shim that's 7 thou. Now this brings it all to 0. So how does it end up with some clearance for when the crankshaft, say, gets longer as it heats up? It's built into the gasket. So the gasket has its original thickness and then its compressed thickness. So you want to get the compressed thickness and then figure out what that's going to be. So I'm going to have to measure the gasket and see what it is compressed, or estimate what it's going to be compressed. Plus, I know I'm 7/10 shy here, and then I'll figure out what I'm going to do. So that's all of that's involved in all this. You go, yeah, it's just a little one-cylinder engine. To make it, put it together, and to assemble it properly, you need to do all these dimensions to come up with the unknown number, which is the shim that's going to go right in here. Now let's see what's on the Barbie here. Oh, look at that crankcase. All right, I don't have an oven to heat these with. Oh, temperature is good. Okay, so leave that for the other side. Then we'll move over to the bench here. And this is the time to install the seal. So I'm going to actually, so I don't grab the wrong thing and make an owie, I'm going to put the seal in there. Okay. And of course we have to make sure it's facing the right way, which it is. And then I'm just going to seat it. There we go. It is seated. So actually I'm going to turn it over and make sure that it is seated before I take the tool out. And there we go, and the tool fell out. Perfect. So now we've got our seal in place. That's what we're looking for. That's perfect. So now I will get the crankcase flipped over and we'll put the crankshaft in. So I've got it on a couple of boards here. And this is the PTO side, so we're going to use this part. This end of the crank, going to make sure the rod's in the right place. And then just going to drop this in. Well, that was a good fit. So that's what I was looking for. Get the crankcase heated up to expand it. I don't want to have to use a hammer to put it together. It needs to go and slide in with the crankshaft being expanded. The crankcase half being expanded and the bearing is just at room temperature. So we'll put the gasket in place. And well, now I have to heat up the other half. So that's next. We're going to put this one on the Barbie and warm it up, and then we'll put the seal in that one too. So if you remember, I was 7 thou under on the shim pack that was going to go on the crankshaft to make it 0 out. And then the clearance at that point, which was from 8 to 12 thousandths, is made up on the center separating gasket here. So what I decided to do was I had a couple of different thicknesses of these gaskets. So I was looking for 0.012 inches overall is the max, and this is 5 thou compressed. So of course the gasket is 0.5 thou. So I get my 12 thousandths end play on the crankshaft, which is maximum spec. It was 8 to 12. It's a free air engine. I'd rather have it a little bit on the max side. So that's what it is now when it's all going to be assembled, is 12 thousandths end play on the crankshaft. Okay, here comes incoming of the heated part. Now on this half, on the mag side, there's no lip on it to keep the seal from going all the way through. So I'm placing it on a, oh, I can feel the heat coming off of that. For sure. Get my other glove on. Okay, and I'm just going to push this down in until it stops. There's a couple of little teeny little nips things on it. On the other side, little small marks on there, but yeah, there we go. That looks good to me. All right, perfect. You see now if I can get my little tool back out. Oh, perfect. All right, let me reset, remove the camera over here. Hopefully I get this. Won't be any retakes on this because this is all hot and it's a time-controlled deal here. So slip that on. I've taken the key out so that it doesn't scratch the seal. Push that down firm by hand. Now I need to put the screws in it that hold it together. However, I'm going to tighten them up now, but I just have to walk away from this for it's near the end of the day. So tomorrow morning, I'll when it's all cooled off and normalized, I'll torque these. So I'm just going to run them in with the screwdriver right now and sort of snug them up, and that's it. Because obviously the crankcase is expanded. I mean, I've heated it up, and I'd rather end up with it not to with it all the same size before I put the Loctite on these and tighten them up. So we'll just get these all snugged in, and then I can I still, one more thing to do yet. I still have to give the crankshaft a little tappy tap on each end right now while it's still warm. So not making them super tight, just enough, hold it in place. There we go. Okay, gloves is back on. Need my small mallet here. So dead blow hammer and a couple of little tappies on there. Done. So the whole engine assembly now has returned back to room temperature. So each one of the crankcase screws, I've removed them individually and put blue Loctite on them and torqued them up. Next is cylinder head. So I haven't cleaned it, as you can see. I'm going to just run it on the surface plate and see how flat it actually is, because I'm sure I'm going to have to resurface this. I had to do it on the other engine. I had to do the top of the cylinder and the head because it was warped. It's a free air engine, so imagine it's been hot a few times. So as you can see, after a little, I was using some 220 paper, and you can see it touches here wherever it's clean, but it doesn't really touch right there, and it doesn't touch there. So this one I'll do carry on with the 220, and then I'll polish it up with 600 or 800, and then I'll clean it all up. So as you can see, I have really nice contact all the way around on the head, and I've given it some on the top of the cylinder as well. Really didn't take much material off, but let's start out with something that's flat. Give the head gasket a head start. But while I'm waiting for the cylinder and the head to normalize temperature, because of course I scrubbed them in hot water and soap, I'm going to put a little cleaner, a little spray cleaner on my gasket. I'll let it dry and then we'll coat it. Now I'll be using this product spray onto both sides of the gasket. It needs to be agitated for a minute. So I'm going to get shaken. So let's apply the first coat. I'm doing it inside the can because the overspray just puts this copper everywhere. And it makes quite a mess. So I'll just let it set. We'll get another coat on it after. So 30 seconds between coats. And you have to shake the can the whole time. And we'll go again with another coat. So there's 4 coats applied. I'm quite happy with that. It's nice now that there's actually a product that you can get that works really well on copper gaskets. Years ago, the copper gaskets on the race cars, we used to use silver metallic paint because it had the little, metallic particles in it. This has copper particles in it, so pretty cool technology. So the temperature is all normalized now after washing it. And let's put the head gasket in. So I'm going to hold it only by the edge and place it on. There we go. Good, I didn't touch it anywhere. On these cylinder heads, it's a different shaped combustion chamber. So it's flat on this side. This is the exhaust, or goes towards the exhaust. And there we go. We'll get some washers and nuts and torque the head on. The cylinder head is completely installed and torqued to specs. And I've got the engine all plated up, sealed up, so that I can do my pressure test on it. And as you can see, it's at 5 pounds pressure. It's been there for 15 minutes now. So apparently it's well sealed up. So now that I have the short block completed, pressure tested, all done, now the next step is to do the ignition. I'm going to do that in a separate video. So thanks for watching today. I appreciate the time you spent with me. Have a good one. Bye now.